Hello everyone, today we'll be going over our data structures and algorithms course. Today focusing on linked lists, and without any further hesitation, let's get started. So linked lists overall are very similar to arrays. The only key difference between the two is that linked lists can be stored dynamically, meaning that we can add different elements inside of our linked list continuously compared to arrays, where arrays, as mentioned before, have a fixed number or a fixed amount that can be stored inside of the array. It is constrained. And the real kicker between linked lists and arrays is that linked lists are typically built on the backs of nodes, where nodes are storing different values of data inside of themselves to be able to chain together and be able to build the list accordingly. And as stated before, linked lists are similar in structure to a chain where one element is connected with another. If we look inside of our example that we have, as mentioned before, they are comprised of nodes, but a linked list has a head and then a series of nodes depending on the amount of data one wants to actually put inside of the list. So it would be connected between head, next, next, for instance, for a linked list of 3 different elements in total. And we typically print at the head of the linked list at the very start, so that way we can see the whole chain of data accordingly. And linked lists are very efficient in general. Their time complexity is O of 1 for searching and shifting, unlike arrays where it would be typically O of n. And there are different techniques to be able to actually solve different problems with arrays, but right now we're just focusing on the basics of data structures and algorithms accordingly. And with the efficiency of linked list, we therefore have a space complexity of O of n as well, just by general principle. And now let's go over our problem. So in our linked list problem, we are tasked with the following. The first thing we need to do is actually reverse a linked list. The second part, we need to print out a singly linked list and then a doubly linked list. I'll explain the differences between the two as we're going along, but to kick things off, let's focus on developing our reverse array. So, to be able to get things started, first thing that we need to do, we always need to include our libraries. And if you can do this on Visual Studio Code along with Xcode as well. So I'm just going to include iOS stream using namespace std. And the first thing that we need to do, linked lists are always comprised of nodes. So we have class node. And I'm going to make this a public variable with integer of data, node, next, to be able to initialize. And then I'm going to initialize the value by node, int val for data, value. And then next, we're going to initialize by putting in a null pointer. And this is how we initialize our nodes accordingly. Now the next part that we're going to do is that we're going to print out a singly linked list, which is just typically a linked list that goes in one direction. And I'm going to make this a public variable as well. But I'm going to first make our class singly linked list. There we go. And then we're going to first have our head, since linked lists have heads to start with. And then we're going to initialize our function, singly linked list. Head has nothing yet. We set it as null pointer. And then we're going to put our functions being insert, reverse, and then print linked list. So, starting off with the first one, we're going to go with insert. This is how we do it. So we're going to do void insert int val node, new node is equal to new node val. Next one will be the condition if the head is equal to the null pointer. That means we say that there's nothing already in there. And that means that we're going to declare head to be the new node to start with, and we're going to be expanding our linked list dynamically. And then So then the next part will be, we'll do this technique called swap, which means we're going to have a temporary node set up as a head. And while we are looping throughout our linked list, because we're going to have a set of values that we will have inside of our main function, which will be comprised of test values to put in. The numbers we get from our main value are going to be inserted inside of this function that we have. So going back over here, while the next temporary node doesn't equal null pointer, indicating that there is a new number, that means we're going to declare temp to be temp next. And then we will also shift over temp next to be the new node. All right, and now the next one we'll be doing, I'll actually just put the semicolon right here for the sake of it. Now we will be reversing, and we do so by void reverse with this function here. Then we'll have node previously with the null pointer. We're going to use this, and we're going to apply a swap technique. Node current equals head. Node next is going to be the null pointer, because we already know exactly what the head is, and we're just going to be expanding upon that. I apologize on that. That was a syntax error. There we go. Then while the current doesn't equal null pointer, that means we already have numbers that are already inside, and we've already inserted all the necessary elements or any other piece of data inside of our linked list. While there are elements inside of our linked list, we are going to do the swap technique again. So we have next current, which is our head, indicate the next node, and then the current next equal the previous one, and finally the previous one equal the current head, and then the next one will be that. Finally, doing this entire swap head previously over here. So we technically have two different swaps that we have. One, we're going to be focusing directly on the head that we have, and then we're also focusing on the other nodes as well. So we have other nodes, and then we have swapping the head, swapping the head, swapping the other nodes. And finally, we're going to have our function void print list, which will be the node temp equal head, and while the temp doesn't equal the null pointer, because we assume that there are numbers already inserted or any other form of element, we're going to count temp data, and this is how we output, and then temp next, so that we'd still in the loop until there are no other elements inside. That means we assume that we're already at the end of the list, and that means we'll just end that. Now, to be able to test this bad boy out, this is what we will do. We are going to do our function call of simply linked list. I'm going to take this, and I'm going to put this here, and call this a list. So that way we're calling on this function for other ones that we will be using. So insert reverse print list, and that means what we'll be doing is that we're going to insert values. We do so by list.insert, and it looks like it accepts integers, since we have already declared in particular on the type of data that we're actually going to be putting in. So we're going to put 1, 2, 3 right here, and then we're going to print out our original list, just so you can see the difference. So that means count original singly linked list. List.print list. And then we're going to print out our reverse linked list, singly linked list. We're going to do so by count by first list dot reverse, and then we're going to have count reverse singly linked list. Finally, we're going to be printing out. And finally, for any type of base case, we always return 0 in C++, just based on the nature of it. And so, let me just zoom out of here for you folks so you can see. Let me clean this up a little bit. There we go. So let's run this. And here we go. So we notice in particular, just zooming in over here, we notice our original singly linked list is going to be 1, 2, and 3, as indicated, since we have already set up what our head is. Our head's going to be 1, and then we reverse the singly linked list by 3, 2, 1 accordingly. Hence over here in these following functions, I'll also put this down below as well in the comments to be able to give you folks a little reference over exactly how we went about this whole problem in general. And as stated before, just always keep in mind about space and time complexity for O of 1 and O of n. And now let's go over doubly linked lists. So doubly linked lists are a type of linked list in general that allow the connectivity of elements for both forward and backward, unlike a singly linked list where one needs to actually iterate directly from the head. And this is really efficient in terms of the time complexity whenever we are storing or deleting or searching a specific element, for everything is already connected based on each elemental node inside of the doubly linked list. So to be able to construct everything and to be able to go further in depth, I'm going to first start off with the libraries. So as we know, we do include iOS stream. And then we're going to use using namespace std to save on time. Then I'm going to have a class. Let's call this doubly node. Over here, and it's going to be a public class with data that will be in integers, and we're going to have a doubly node referred to next, and then a doubly node referred to the previous. There we go. Then doubly node we'll have integer of values, and then data with the value, and we're going to initialize our nodes by using null pointer and then previous pointer. Move that out of the way. There we go. So we have that. Just fix that syntax over there. There we go, null pointer. And then we'll have class doubly linked list. We'll keep this whole thing public to start with. We'll have a doubly node referred to as the head, and doubly node referred to as the tail. Then we're going to call upon a function doubly linked list. We'll have head, null pointer, This is how we initialize, and then we'll also have the tail for the null pointer. And so we're going to have our functions. In this case, to be able to just showcase the simplicity of this, we're going to do insert, and then we're just going to print the list. And eventually I'm going to have a key function for a doubly linked list, but we're going to save that for later. In the meantime, we're going to focus on the functions for insert. So void insert int val, where we have doubly node, new node, equal new doubly node for the value. And we're going to have this condition statement if the tail does not equal to the null pointer, for we need to determine, as we're inserting elements inside of our linked list, we'll have tail next equal the new node, and we're going to have the new node the previous node that we have equal the tail. Notice how we are using the swap technique like we did beforehand in the singly linked list. And then we have to redeclare tail equal to be the new node, and then if there is no element inside of tail, then we're going to declare head to be the tail and indicate it as the new node, we assume on that case. There we go, so that's insert. And then we're going to be printing the list, so void print list. There we go, and the way how we'll be doing that, so we'll have the doubly node temp equal head. We'll do a swap technique as usual, and while temp doesn't equal null pointer, cal temp data next. Small syntax. And now we're going to have our main function that we have over here. We'll have doubly linked list. Call it list. And then we're going to call upon the function list insert integer value. And we're going to do this for 3 elements as well. So we're going to have 1, 2, 3. And then we're going to output our doubly linked list. List.print list over here. And as our base case, we will return 0. So let's build. Let's succeed it. Let's run this. And it prints our doubly linked list accordingly, much like in the case of singly linked list. Now, a key function and a key functionality with what makes doubly linked list very, very efficient is the accessibility to be able to delete, insert, and or search for different elements as well. For we're able to search, instead of directly going at the head like we would in a singly linked list, we're able to search specific elements throughout our doubly linked list, since everything is comprised inside of a chain. So what I'm going to be doing is that I'm going to have a temporary, I'm going to have another function called void delete node. It's going to have the values, and then we're going to have doubly node, a temporary one, set it as the head, And while the temp doesn't equal null pointer and temp doesn't equal data, doesn't equal the value, I'm checking so far. We are going to set the temp node to be equal to the temp next. We're going to be going for the next one. And then we're going to have a series of Boolean conditions as well. In this case, where we'll be checking to see if the specific node is not found. We're just going to be returning saying it's not found. Then we'll have another case, and mind you, I'm just doing edge cases right over here. If the previous temporary node has a value, we set the next one accordingly. Then if the temp node, next node, has a value, we'll see about the tail. Otherwise, go for the head. And finally, we delete the temporary node. So these are the three different if statements that we're going to be checking between the head and the tail. So doubly linked lists are widely popular for sliding window techniques as well, especially when one goes further in depth in LeetCode and Line 75 and C++. Namely, they will be able to utilize some techniques of doubly linked lists as well. So now I'm just going to take care of these edge cases that we have over here. So if the temp equals null pointer then we're going to output node not found. Here. I'm going to have another if statement here. If the temp with the previous doesn't equal the null pointer, I'm going to set temp to prev, and the next one equal to temp next. Otherwise, we're going to set the head to be the next one until we start finding the specific value that we are looking for. There we go. And then we're going to be focusing on the tail side. If the temp next doesn't equal the null pointer, temp next. And previously, much like in the case of what we did for the head over here, we're going to be focusing on the tail. Now we'll have temp be the previous, else we'll have the tail equal to temp previous over here. Now checking to see if there is a number or no number whatsoever. Finally, we will delete the temporary node. So we'll have delete temp count node with value val deleted. There we go. Now for the next part, I'm going to delete our node. So list.delete node. Let's go with number 2. And then we're going to output our new doubly linked list with deletion. List.print list. There we go. Yes, indeed. Okay. And we can see right here that this is our new doubly linked list, along with our doubly linked list. Compare the two accordingly. Notice how we applied the swap techniques that we have already situated right here for the tail as well as the head. And we have a temporary node that we use as a placeholder, really. We put it as head to assume that it is at the beginning, and then we're going to be scanning while we are going through our array. In the delete function, we're having these Boolean conditions really to be able to check where the specific value is and to determine if it has a number or not a number, but then we have to check to see in particular at that specific value to be able to delete the temp. For this is just a common function that is used widely within the C++ libraries, so that's why we're able to call upon delete, and it will completely delete the following value that we have here. And I will put this in the comment section as well, so we have a full look and understanding between them. So let me see if I can zoom this out for a second. You folks can get a good look. So here's our main, here's the doubly linked list, and then that's the beginning as well. And so yes, this was doubly linked list as well for a linked list data structure series. Hello everyone, thank you again for taking time to watch this. If you found this video helpful, be sure and feel free to please like and subscribe. And if you have any other questions as well, feel free to put it in the comments section. And as always, take care. Cheers. Bye-bye.